Hello, welcome back to another video. So today we are going to discuss about the editorial for weekly contest 442, and as you can see I was able to solve all four problems. So we will discuss the solution for all four problems. Overall, I think it was a pretty good contest. Questions were mostly based on some mathematical property or some kind of equation solving. So I pretty much enjoyed the contest. So let's start with the problems. First is maximum continuous ownership. So we are given an integer n representing n into n cargo deck ownership, where each cell can hold one container of exactly W weight. However, the total weight of all containers, if loaded into the deck, must not exceed ship's maximum weight capacity. So what we need to do is we need to return maximum number of containers that can be loaded onto ship. For example, here n is equal to 2 and we have basically 4 cells. Now if we fill weight of 3 in each cell, total weight would be 12, which will not exceed the maximum weight constraint. So answer here is 4. Similarly, in second case, we total have 9 cells, but max weight is 20 and W is 5. So at max, we can fill 4 cells. That's why answer here is 4. Now this is a pretty simple question. So we basically need to check two conditions. So let's say we can fill all n into all the cells. Then what we need to check is that maximum weight must be greater than equal to n into n into w if we are filling all of them. If we can't fill all of them, then what we need to do is we need to fill whatever we can. So that number would come out to be max divided by W. Basically, answer here is max divided by W, but you also need to check if it exceeds n into n cross n value, because maximum cells we have is n cross n and we cannot fill more than that. So this can be solved into one one-liner. So we just need to return minimum of n cross n and max weight divided by W. If this exceeds n cross n, then this minimum will take care of the exceeding condition. That so this was first question, pretty simple, just a one-liner solution. Let's move to second one. Second one is also an implementation problem, not so difficult. So we are given a 2D integer array properties having dimension n cross m, and we are also given an integer k. We define a function intersect a comma b that returns number of distinct integers. Now here a comma b are arrays. I got confused while reading this. I thought this is a property where you add an edge because it was saying an undirected graph, but it is an intersect function is on two arrays, and we need to construct an undirected graph where each index I corresponds to properties of I, and there is an edge between node I and node j if intersect of properties of I and properties of j is greater than equal to k, where I and j is from 0 to n minus 1 and I is not equal to j. So this first test case forms a graph like this, and we need to return the connected number of connected components in that resulting graph. Now 0 and 1 has a age in it because zero's properties of 0 is 1 comma 2 and properties of 1 is 1 comma 1. Now the common number of distinct common elements in both the arrays is 1 itself, and the number is greater than equal to k. That's why there is an age from index 0 to index 1. Similarly, you can try for 2, 3, 4, and 5. You will find this type of graph. And once you find the graph, you need to return the number of connected components. I don't think there is any much more here to explain here. I will just go through the code. I think this is a implementation heavy problem instead of logical problem. So first of all, take n and m, then initialize an adjacency list, then iterate for each index 0 to n and create a set st which stores all the unique elements of uh, in the array at index I. Now you will also in the same for loop you will iterate over every element from I plus 1 to n. Now this set I'm creating to store common values. So to find common values, I'm iterating over the jth array and checking if it is present in ith array. If it is, I will insert it into result set. And if the size of that result is greater than equal to k, then I will create an edge in our adjacency list. Now, once our adjacency list is created, we just need to find the number of components in it. So to find number of components, again, it's a simple thing. If you are not aware of it, you can go to CP algorithms website and check it out. So, here you can find all the resources or on graph and codes also. So what it does is we are iterating over each element from 0 to n. Now if they are not visited, then I will run a BFS and visit all the nodes which are possible. So in this case, if I start from 0, I will visit 1. So I found one component, one connected component. Now I will go to, when I was processing 0, I also marked 1 as visited. Now if I go to 1 again and find that 1 is already visited, that means it was already a part of connected component. I don't need to start traversing that component again. So that's why this visited vector is used. And whenever I find a non-visited element, I will just increment the number of components in it and finally return that answer. So if you still don't understand it, I would say just go through this graphs blog. You will find all the details regarding it. I'm not sure why it is taking time to load, but it will. Yeah. So here you can see finding connected components. You can find it using DFS, BFS, whatever you like. This is an interesting problem. Now we are given a two integer array, skill and mana of length and n and m respectively. And in a laboratory, n wizards must brew m potions in order. So each potion has a mana capacity mana of j and must pass through all the wizards sequentially to be brewed properly. The time taken by ith wizard on jth potion is skill of I into mana of j. I mean, if you are watching this editorial, you might have read the whole statement. So I will just skip this explanation and uh, I will try to simulate this solution. Now, here what we need to find is minimum amount of time required so that all the potions are brewed properly. Now, we are brewing potions in order from 0 to m minus 1. I think, yeah. So m represents mana, yeah. So from 0 to m minus 1, and we have widgets from 0 to n minus 1. Now, for first portion to be proved, we can say that we can start at 0. Now, when we start at 0, the wizard 0 will take 5 minutes, 5 time units. So how is that 5? So skill of 1 into mana of 0. Skill of 0 into mana of 0. Which 1 into 5, which would be 5. Now wizard 1 will take 25 unit of time, because skill of 1 into mana of 0 is 25 and plus the time taken by its previous. So wizard 1 will be done by 30 time units. Similarly, wizard 2 will be done by 2 into 5. So 10 plus the previous time. So 30 plus 10, 40. And wizard 3 will be done by 4 into 5, 20 plus previous time 40. So 60. Now here we can start by 0 itself. But now you might think that why can't we start the second timer earlier than 52? Now the issue here is that, let me just, so 0, 5, I don't have my writing pad, so I'm trying to write it on with mouse, so just bear it with me. Now second, let's say we start, answer here is to start with 52, but let's assume we start earlier than that. So if we start from 50, so if we start from 50, the time taken by wizard 0 would be 1, because scale of 1 is 1 and mana of 1 is 1. So 1 into 1. So this would be 51. So I'm just skipping the counting. This will take 5 times and 2 times. So this would be 56. This would be 58. 5 plus 2 plus 4. This would be 62. Now, why doesn't this work? Because of the constraint that once the wizard 3, this is start time, this is wizard 1, this is wizard 2, wizard 3, wizard 4 in one based indexing. So I'm saying is, once the wizard 3 done completes the brewing of potion 1, it will pass it to wizard 4. Now when it passes it to wizard 4, wizard 4 is already brewing the potion 0. As you can see, its end time is 60. This is where the condition fails, because we cannot pass another potion to a wizard who is already brewing a potion. We have to wait for it to complete. So if we have to wait for it, we will always have to come back and update our start time. So if we start 50, it fails. If we start by 52, it would come out to be 53, 58, 60, and 64. Now here it doesn't fail, because once it is completed on 60, it will pass it to wizard 4, and at 60 wizard 4 will also complete its potion brewing for potion 0. So for each potion, what we need to do is we need to find a starting time, minimum starting time, which does not fail any condition. Now based on this, so what I thought initially was I can use binary search on this, but the constraints here are very tight, so you cannot use, I hope you cannot, I think you cannot use binary search. So I thought of creating some kind of equation. So let's say if I keep my starting time as X, now to brew potion I till jth wizard, it would be some prefix skill of j, that is the skills total till sum of skills total till jth wizard into mana of I. So this will take skill of I into mana of j portion. This will take skill of I plus 1. So we can take mana of j as common, and we can add all those remaining skills, and it would be a prefix sum of those skills. So this would be the time at jth when at jth wizard, when we are reaching at wizard j. So x is the considered start time. Sum of prefix of j is sum of all the skills till j index, and mana of I is just the required mana for brewing potion I. Now this should be greater than or equal to. So this should be greater than equal to the wizard, so previous time of j plus first wizard. As you can see, if this was 60, what we want is it should be greater than equal to the time at which it ends for previous portion. So x plus sum of prefix into mana of I must be greater than equal to the time required for j plus 1 wizard to complete its brewing for previous portion. As you can see, I also wrote it in my Sublime when I was trying to solve it. I don't even have a book, I just wrote it on my Sublime text, and this should be than greater than equal to. So this is the equation which I came up with and I solved it. So here what I'm doing is I'm maintaining a NDP array which stores previous time of each wizard, time taken for each wizard to do previous portion, and some prefix I don't need to calculate it, I can just iterate and maintain a sum variable, and man of I is just fixed. Now this would be we need to check x for each array, each wizard. So x must be greater than equal to previous of j plus 1 minus this value, sum of prefix and into man of j. Let's call it d. Now we know all the values of x from all the wizards. So we need to take max of x such that it satisfies all the conditions as it is greater than equal to. So this was the whole solution. I think this problem was difficult than fourth problem. I would say I found it more difficult than fourth problem. So let's just see the solution. First of all, I'm declaring n and m2 as skill size and m size. I couldn't use m because I was using m as manas array. So time ending time for each wizard or proving previous portion. Now for zeroth portion there would be no previous portion, but we are starting from index 1. So from first portion, for first portion we are just uh, making the base case where the time required for zeroth portion, start time for zeroth portion would obviously be 0. So in that case, for uh, brew zeroth portion by zeroth wizard would be m of 0 into s of 0. Now to brew zeroth portion by ith wizard would be m of 0 into s of I, but I need in time. I don't only need the time required for it. I need in time. So in that case, I will also need to add time taken by all the previous wizards. Now, now I will iterate from 1 to m2, and First of all, I will declare x as NDP of 0. Now, we cannot start this, the starting time. This should be at least its previous starting time. It cannot be less than that. So that's why I'm initializing it with NDP of 0. Then I have declared a sum variable to store the prefix sum of skills till jth wizard, and a new DP vector to exchange and rebuild NDP. So then I'm iterating over J0 to N. So wizards taking sum into it, finding the value of D, which is sum into M of I, which is this one, sum of prefix of J into mana of I. Now if J is not equal to N minus 1, I'm taking X with max of X, comma, and prefix NDP of J plus 1 minus that D value of D. And I'm taking max of it. If it is equal to n minus 1, then I'm just taking its above value. I don't think this is even necessary, but yeah, just in case. And then I will rebuild my NDP with starting time as x for further portions, and I will just make it swap them. So make NDP equal to DP. So rebuilding that NDP. So this was the third problem. I mean, this is difficult than fourth, I think. I solved fourth problem faster than fifth, I guess. And my rank is 474, but I think it would drop down by 50 or 100 because, I mean, someone solved it, all the problems in 2 minutes. So let's start with the fourth problem. Fourth problem is minimum operations to make array elements 0. So we are given a queries 2D array where queries of I is form of LR, and each queries of I defines an array of integer nums consisting elements from L to R. Now, in one operation, what you can do is you can select two integers A and B, and from the array replace it with floor of A slash B and floor of B divided by 4, A divided by 4. Now we need to return minimum number of operations required to reduce all the elements of array to 0 for each query. So there are two queries. One is 1 to 2, so nums is 1 to 2. Now this can be done in single operation. So we can, in one operation we can choose 0 and 1 and divide it both of them by 4. We'll get 0 comma 0, and so number of operations required is 1. For queries 1 we have three numbers 2, 3, 4. First we can do 0, 1, 1, 2, so it would come out to be 0, 3, 1, and then we can do these two, and uh, in two operations we made the whole array 0, 0, 0. So for first query it took one operation, for second query it took two operation. So total is 1 plus 2, that is 3, and answer here is 3. Similarly, you can go to this query 2, 3, 4, 5, 6, and these are the possible operations. And in 4 number of operations, answer is 4. Now let's ignore this operation and let's just try to find for each element how many times it takes to replace a with 0, to replace any number with 0. So let's say x is my number. So I will keep dividing it by 4 until it becomes 0. Now let's just create a number line, try to see what would be my answer. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So for 1, it would be 0, it would be 1, for 2, again 1, for 3, again. For 4, first operation, it will go to 1, and in second operation, it will go to. So for 5, again 2, for 6, again 2, for 7, again 2, for 8, again 2, for 9, again 2, 10 also 2, 11 also 2, 12 also 2, 13 also 2, 14 also 2, 16 also 2. 15 is also 2, but 16 is 3. So 16 will reduce to 4, 4 will reduce to 1, and 1 will reduce to 0. So 3. 17 is 3, 18 is 3. Now if you keep doing this until 32, not 32, until 64. For 64, you will find answer as 4, because 64 would be 16, then 4, then 1, and then 0. So this type of pattern, you can easily recognize the pattern that if you have to find a number of operations required for x, what we need to do is we need to find log 4 of x and add 1 in it. If it is not a perfect, and I will have to add 1 if it is not a power of 4. So for 8, I will find log 4 of x. It would come out to be, yeah, this if it is power of 4. No, it would be just log x. I don't need to consider this. Yeah, so for 4, yeah, 1 should be added when it is a power of 4. I got confused here. So for 4, it would be log 4x would come out to be 1. Yeah, it would be log 4x plus 1 always. So for 4, it would be, I mean, it depends on your implementation, but yeah, basically it would be floor of log 4 of x plus 1. So for 4, you will find log 4x would be 1, and 1 plus 1 would be 2. You don't need to worry about this. You just need to understand this pattern. Now, the pattern basically changes powers of 4. So it would change on 1, it would change on 4, it would change on 16, 64, 256, 1024, I think. Yeah. So it only changes on these, and this would go till 29, because 29 is the limit of 29 is the constraint on L and R. Now this, if we create a vector of this elements, size would be around 16 to 20. I'm not sure. I don't know exact value, but it would be a limited value, a constant size vector, you can say. So what what you can do here is, based on this pattern, you can simulate the pattern on this vector using a sweep line type of logic. Now what that sweep line is. So let's say I need to find my answer from 18 to 70. So what you will do is you will divide this segment into multiple parts based on these items as your breaking point. So 18 to, I will break it till 31. From 32 to 60, 63, and 64 to 70. Now what I did here is I started from L, but I went till so this should be 64, 63. So I started with 18. I found the number which is greater than 18 in my vector, and I took -1. So I broke down the segment from 18 to 70 into two parts, 18 to 63 and 64 to 70. Now 18 to 63 will have same answer, same number of operations required to perform on it. So 18 has 3. Now try to find it for 63. It would also come out to be 3. So my answer for all the elements in this segment from 18 to 63 would be 3. Similarly, my answer from all the elements from 64 to 70 would be 4. Now, the idea here is to break this segment based on these elements. So based on powers of 4 such that each segment has same answer. Now, total here would, I don't need to iterate over this segment. I can just see that it total here would be 63 minus 18 plus 1 into 3. So total number of operations. And here it would be 70 minus 64 plus 1 into 4. So what I'm doing is I'm basically finding total number of operations required for each element in L to R. So let's just see that how I'm doing it. So first of all, I have declared an answer variable and I'm creating a power vector which stores all the powers of 4 until 1e9. So I'm pretty sure that would be less than 30 because the 2 raised to power 30 is itself greater than 1e9. So 4 raised to power 30 will always be greater than 1e9. So I'm just created a for loop till 30, but I think it will break on 16, 17, not sure exactly. Now for all the powers, I'm storing answer. Now PW of 0 would be 1 and answer for 1 is 1. Now PW of 1 would be 4 and answer of that is 2. So what I'm doing is I'm storing its answer based on its previous element and I'm just incrementing it by 1. So now what I have is I have this vector of all the powers and answer mapped with it. So for 1 answer is 1, for 4 answer is 2, for 16 answer is 3, for 64 it is 5, 4 and like this. Now what I will do is I will iterate on my queries, store L and R, and I have declared a current variable which is to store total number of operations required for this segment. Now I have declared a J variable which is initialized with 0, and what I'm doing is I'm doing this breakage. Now if power of J is less than equal to R, I can skip them because the starting element L is greater than equal to the value itself, the power of 4 itself. So I can skip them. I don't need to break at those points. Now for then I will start iterating from J to PW.size. So whatever J was giving out from this. Now if R is less than PW of J, that means the right limit. So when we reach at 64, let's skip this and try to understand this. Let's skip this. Now here we are at position where PW of J points to 64 and 64 is not greater than 70. So it comes out, it satisfies this else condition. And what I'm doing is I'm adding PW of J minus L. So 64, instead of 63 minus 18 plus 1, what I can do is I can just say 64 minus 18. So basically some rearrangement, that's it. So 64 minus 18 into MP of PW of J minus 1. So MP PW of J points to 64. I want it to point to its previous element's answer. So MP of 16, and what is MP of 16? This 3. So 64 minus 18 into 3 would be added into my current variable, and then I will update my L to the start to that value. So 64. Now starting point of my segment would be updated to 64. Now what I need to do is I need to find answer from 64 to 70. Now j will be incremented and this will be satisfied because now 70 would be less than equal to 256. Now I only need to worry about R2L segment. So 70 minus 64 plus 1 into MP of PW of j minus 1, that is 4. Now I what have in current value I'm storing total number of operations required to make all the elements in L2 are equal to 0. Now if thus those total number of operations are 6, what I can do is I can just keep dividing 2. So in each operation the number of required operation will decrease by 2. So if I perform one operation, I can consecutively make two elements, uh, decrease the number of operations by 2. So I can do two operations, again 2 and again 2. Now you might say that these two numbers should be distinct. Now the proof for that is that this number line is pretty consistent. So if you have something like this, you will always find that you can always take two unique elements and keep doing that operation, and so you will always have an option to choose two elements. So you can choose the first one and then last one. So you won't come to a point where there is only single element remaining which has a non-zero value. So something like this. Let's say I have a distribution of 1 to 7. Now what I can do is I will do first operation on first and last, and then I will do two operation on first and last. So array would come out to be 0, 0, 4. Now this is happening because 7 is greater than sum of its previous element. Now, this is a mathematical proof. I mean, if you are not aware of it, you can just guess this, but this condition will never satisfy here because this is a continuous increasing array with constant. At max, what you have increased is just 1. So this condition will never satisfy. You will always find such an arrangement such that you can decrease operation always by 2. For 6, you will need 3 operations. Now, if it was a case when the number of operations is odd, then you will require 4 operations. So, you will reach a case where you only have to perform one operation, and what you have to do is you can choose these two elements and perform that operation. So, answer here would be 4. So, basically, I will add current plus 1 by 2 in my answer and finally return that answer. I mean, this was very interesting question. If you have idea about sweep line, you can solve it. So I pretty much enjoyed this contest. I participated after a long time as I was shifting to Bangalore. But yeah, I plan to solve, plan to participate in more contests and also upload videos. And for today, I guess that's it from my side. And thank you for watching.